A warm good morning, class. I'm Karthik, Assistant Professor, Mechanical Engineering Department from SNS College of Technology. So here we are going to see most important topic in metallurgical world is nothing but failure mechanism. Okay, we'll see deeper. So you can see these pictures, right? So you can see these two pictures. Then the first one you can see this is a ship. This is Liberty ship of British. You can see a very long crack or a break here, and this is another failure of a material. You can see a large crack which propagates from one side to the another, right? So the third one is you can see that it's a broken shaft. Okay, maybe it's a helical gear shaft. So in these three things, what is the main common thing, common one way what you're finding is failure, right? So here the Liberty ships got broken. Here the crack has propagated, and some void has been created. You can see there are some more cracks in this helical gear. So before employing any material for an application, the major thing what you have to study is this one is material failure or failure mechanism, right? So in this you can see here, you can see uh, a failure or a fracture, right? A failure or a fracture is simply, you can say that it means that a material is getting broken into two or many pieces, right? So the main thing in this fracture or failure is load. So when a load is applied, eventually the material won't get failure. Once the load is applied, it will withstand for a particular or critical uh, limit. Once the critical limit is reached, even if we keep on applying the load even after the critical limit, the material will get failed. Okay, in that condition, a simple fracture can be as I said before, can be said as it is breaking or separation of a body or a piece or a material into two or more pieces upon a response to applied stress. So here the stress can be anything. Sometimes the stress can be in the format of mechanical loading. Sometimes it can be due to thermal loading, right? So here, due to this applied stress or applied load, the material get fractured. So that is the simple fracture. Here you can see the temperatures that are low relative. That the Tm what is shown here is nothing but the melting point temperature of the material. So when we comes into the fracture mode for a material, there are four types of fracture mode that can be occurred in a material when it is applied in the specific applications. First is ductile fracture, brittle fracture, fatigue fracture, and creep. So we will see these fractures one by one. The first one is ductile fracture. In short, we can explain this ductile fracture in a simple way is that see, if you take a tender stick which is broken from a tree, you can see once you broke it into two pieces, you can see some cup and cone fractures, or some cup and cone like structure is formed like this way, right? So here you can see like this way. So in that manner, you can see it is not completely broken, or if we stick it together, we can see some ups and downs, some ups and downs, mm, thin structures can be seen. That is nothing but the crack grown area or crack propagated area. So here you can see in this ductile fracture, you can see there is a plastic deformation occurs. So this, as I said in the said, there are some ups and downs that will be seeing in the later slides. That's are nothing but the crack movement area. So the ductile fractures happened only with the significant plastic deformation, means that it will show that it is going to break, right? Means that it will show some plastic deformations before getting break, before getting fractured. So that this ductile fracture will be helping, or will show some indications, so that before the particular material is going to get failed, he can easily identify the particular material, so that we can change the material before the failure is going to occur. Okay, so that's all for today. We'll see the rest of the fracture modes in the next class. Thank you.